Good morning. This is the homework 25 video, which is page 127, 1 through 4, and 11 and 12. 1, 2, 3, and 4. These are all proofs, and we're going to be using CPCTC, and we are going to be using all radii are congruent. CPCTC just means when you prove the triangle is congruent, all the parts are congruent, all 6 parts. So for problem number 1, you can see the givens. Now we have to set this up in a 2-column proof. And you have these 3 givens. You have AB congruent to DE. And then you have BC congruent to EF. And then you have AC congruent to DF. Now, this is all given. Now, if we mark our diagrams, which is helpful, AB congruent to DE, BC congruent to EF, and then AC congruent to DF. Those were all givens. And then the triangles are congruent. So triangle ABC, which is A, B, C, congruent to triangle DEF. And that's side, side, side. And that's 1, 1, 1, because all 3 sides were in the first step. And so you can see that angle A and angle D match up, correspond in the 2 triangles. And that's what we have to prove. So angle A is congruent to angle D, and that is CPCTC. Right? And then there's a 2 there. I missed a couple things. And that's it. That's what we have to prove. That's what we had to prove here. See, angle A is congruent to angle D. Angle A is congruent to angle D. That is what we had to prove. Now, problem number 2, you have to be careful. Problem number 2 says angle HGJ. HGJ. Congruent to angle KJG. And then angle KGJ congruent to angle HJG. And you can see the reflexive side here that is common with the 2 triangles. So you're going to get this triangle congruent to this triangle by angle, side angle. And then you're going to get these 2 segments congruent by CPCTC. And the proof should be laid out like a 2-column proof. And the solutions to assignment 25 are on the Schoology page. This is 8th period, but it's the same for 3rd period. And the answer keys, I'll just bring that up. Is here. Okay, so now let's talk about number 3. Okay, number 3, you have to read each statement. nicely. Circle with the center at O. Now, once you know you have the circle at the center O, like this, then you can look for the radii. Let me use yellow. So from that O, we know that this is a radius. We know that this is a radius, this segment. So OM is a radius, OP is a radius, and OR is a radius. Now, in this problem, it says that RO is perpendicular to MP. So RO is perpendicular to MP. So that means that this segment, RO, and this segment, RP, are perpendicular. So that means, what does that mean? Perpendicular should be, you should remember that that means the two segments meet at a right angle. Okay? So for this proof, you're going to say that a couple of things you want to say. You want to know that you have to write your first statement and your first reason as the circle with the center O. That's what that means. Oops, it's a 1 there, not a 2. Then you can say that all of these segments are congruent. What I'm talking about is this segment congruent to this segment, and then this segment is actually going to be the reflexive property. Okay, so we will say OM congruent to OP because all radii congruent, and then we will say that RO is congruent to RO by reflexive property. Backing up a little bit, ladies and gentlemen, backing up a little bit, I want you to know that you have to find these two triangles, this one and this one, and those are the two triangles that we have to get congruent. So we have two sides, and then we have this perpendicular thing that we have to deal with. Well, what we can say about this angle and this angle is that they are congruent right angles. Now, before we say they are congruent right angles, we have to say that they are perpendicular. So we have to say that the two segments are perpendicular, and the perpendicular segments, they create these right angles. Okay, so let's take a look at what that looks like. It looks like this. Oop, let me use a thin one here. So step 4 is that RO is perpendicular to MP. And that's given. All right, so RO is perpendicular to MP. Now, here's the big jump. Here's what we have to be sure to do. We have to say that angle ROP, this one here, is congruent to angle ROM. Now, here's the reason. Let's sink in a little bit. Perpendicular segments make two congruent right angles. perpendicular segments, I'm talking about these guys, perpendicular segments, these two here, make two congruent right angles. This one and this one. My diagram's getting a little crazy down here. Okay, so we have two right angles, we have two congruent sides, and then we have the reflexive side. Now there's a few more steps in the proof that you need to get, and look at the answer key for that one because I only have about 4 more minutes for this one. Okay, so number 4 is the trisect one. I think we did this in class, but we look at this and say T and R, those 2 points, trisect SW. That means that this segment, and this segment are all equal. And so now XS, the other given here, XS is congruent, here's XS, is congruent to XW. So we also have angle S congruent to angle W. And that gives us this triangle congruent to this triangle by side, angle, side. Yay! So, if those two triangles are congruent, we can get these two segments congruent here, XT and XR. All right, so you had 11 and 12. So what does 11 look like? 11 says explain why the area of the shaded region is 100 minus 25 pi. The area of a circle is pi r squared. And the radius of this circle is 5. Now, the tricky part is this. Check it out. The radius is 5 here. And this radius is 5 here. So that makes this the square length 10. And so the area of the square is 10 times 10. So we're going to take the radius, which was 5, and 5 squared is 25. So it's 100, which is the area of the square, minus the area of the circle, because the circle is being taken out of the square. All right. So that was 11, and 12 is a little bit of an algebra problem. So with these algebra problems, you want to be able to put these expressions into the diagram. Okay, so they go into the diagram. Angle GOH, which is x plus 24. Angle GHO, which is 2y minus 7. Three y minus 23 is JMK. And then MJK is 4x minus 105. And then OK is 27. And I am out of time for that one. So I'm going to have to make a short little video on that one.